Hi everyone. Today we're going to study radicals and conversion of radical to rational exponent. First, let us define radicals. Radicals are about nth root of a number. Suppose we have a variable b raised to an exponent n, and this is equal to a value a. Then the b, this b here, is an nth root of a. As an example, we have 5 squared equals 25. So this number 5 is the square root of 25. The principal nth root of a is written as, the symbol read as nth root of a. On the general form, radicals will come like this. The small number n is called the index, the a is called the radicand, and this symbol like a box, like a division box, is the radical sign. We have some notes here. The symbol like this is read as square root of x, and the index is 2. Another, the symbol like this is read as cube root of x. Obviously, the index is 3. Now we have some examples of widely used radicals. We have square root of 1 is equal to 1, square root of 4 equals 2, square root of 9 equals 3, square root of 16 equals 4, square root of 25 equals 5, square root of 0 equals 0, square root of 100 equals 10, cube root of 1 equals 1, cube root of 8 equals 2, cube root of 27 equals 3, cube root of 64 equals 4, cube root of 125 equals 5. Those numbers inside the radical sign are called perfect square or perfect cube numbers. The numbers 1, 4, 9, 16, 25, 0, 100, these are perfect square numbers. While the numbers 1, 8, 27, 64, and 125 are examples of perfect cube numbers. Let us go to the relationship of radical and rational exponent. If we have a radical nth root of x, and this is a real number, and the n is greater or equal to 2, take note that n is the index. Then, the relationship of radical and rational exponent is given in this equation. So the nth root of x equals x raised to a rational exponent. So we have a note here, the index, the n, of the radical becomes the denominator of the rational exponent. Next, the radicand, the x, becomes the base of the rational exponent. Let's go to some examples. We will convert radical to rational exponent. So write the following as rational exponent. We have 3 sample problems here. The first one, square root of 5. Second is the cube root of y. The third is the fourth root of the quantity x minus 2. So I put the equation here for the conversion. Let us now solve the first sample problem. The square root of 5 becomes 5 raised to the exponent 1 over 2. So we simply write the radicand, put it as the base, and then in the exponent we write the number 1 over the denominator. We will simply copy the index of our radical. In this case, there is no number, and if there is no number, it is understood to be 2. So the square root of 5, there is an index of 2, so with that 2 we will use as denominator. So the final answer here is 5 raised to 1 over 2. Second example, the cube root of y becomes y raised to 1 over 3. Again, we see the index 3 there becomes the denominator of the fractional exponent. Again, our final answer, y raised to 1 over 3. Third example, the fourth root of the quantity x minus 2. First, we will copy the x minus 2, and then we will write the fractional exponent. So we write the 1 as the numerator over the index here, the 4, we copy that as the denominator here. So 1 over 4. Our final answer, x minus 2, all raised to the exponent 1 over 4. Let us go to the reverse process. Let us convert rational exponent to radical. So express the following as radical. We have 3 sample problems here. First one, the quantity x plus 1, all raised to the exponent 1 over 2. Second example, the quantity 5y is raised to 2/3. Number 3, the fraction 3a over 4b is raised to 3 over 2 exponent. So let's begin with our first example. Now this x plus 1 is the base. We will put all this polynomial into the radical symbol like this, and then for the index we will copy the denominator. In this example, our denominator is 2. So for this, we don't need to write the number 2 here. So this square root of the quantity x plus 1 is our final answer. So for the second example, the 5y is the base. We will put the base inside the radical sign, the 5y. We will check the denominator of the exponent, that is 3. We will put that as the index here. And then the numerator 2 becomes a power. So you see here 5y is raised to power 2. And from here we can simplify our radicand. We can distribute the exponent 2 to the 5 and the y. So it becomes 25y squared. So the final answer is the cube root of 25y squared. Sample number 3, our fraction 3a over 4b. We will copy all this, put it inside the radical sign, like this. Next, we will check our denominator. It is 2. So we will put this 2 as index. Since it is 2, there's no need to write our index because it is understood without any index, it is 2. Next is the numerator 3. We will use this numerator as the power of our fraction. So you see here the 3a over 4b is now raised to a power 3 inside that radical sign. And then the exponent 3 we can distribute to the terms of the fraction. So for the final answer, the 3a cubed becomes 27a cubed all over. The 4b cubed becomes 64b cubed. Thank you for watching. See you again next time.